All right, your answer to number 9 is C, A, 10, E, 11, G, 12, B, 13, D, 14, F, 15, H, 16. For 17, you should have a straight line. For 18, you should have a U. For 19, you should have that little squiggly. For 20, you should have the little hill, half a hill. For 21, you should have your L shapes. For 22, a V shape. For 23, a sideways S. For 24, a horizontal line at y equals 3. 25a is 4. B is 2. C is 5. 26a is negative 1. B is 2. C is 5. 30 is for a domain, negative infinity to infinity. For a y-intercept, 0, 4. For your range, negative infinity to 0 and 0 to infinity. And there is your graph. All right, for 32, for A, you should have negative infinity to infinity. For B, negative 3, 0, negative 3 over 2, 0, 0, negative 3. For D, a bracket on 1. And how about negative infinity to the 1 with a bracket? And there's your graph. For 34, you should have negative 3 with a bracket to infinity, negative 2.5, 0, 0, negative 3, then negative infinity to 5 with a parenthesis, and there's your graph. For 36, you should have negative infinity to infinity, 0, 0, and negative infinity to infinity, and there's your crazy graph. 38, you should have negative 3 with a bracket to infinity, negative 3, 0, 0, 3, 0 to infinity with a bracket, and there's your graph. And for 45, you should have $35, $61, $35.40. For 46, $3, $41, $50, and $46. All right. Then, for the next section, we are going to do transformations. We mastered transformations in World of Functions, so this is all review. Yay! So, let's review it. So, we're going to move to the left. What does our equation look like when we need to move to the left? Well, you should say it has the x in parentheses with plus a number because it's opposite when it's inside. To move to the right, we're going to have x minus a number. To move up, we're going to have our function and plus a number outside, not with the x. To move down, we're going to have minus a number. This is all review, so I'm going kind of quick. For reflections, if it reflects over the y-axis, that means you put in negative x. If it flips over the x-axis, that means you have negative y. So negative on front. To shrink horizontally, this way, that's your x's. And so we're going to have f times a number inside, and that will make us shrink because it's the opposite. If we had divided by a number, that would make us grow. Right, to shrink vertically, you're going to have a number out in front. And if that number is being multiplied, it will grow. If the number is being divided or it's a decimal or fraction, it will shrink. Yeah, you got it? So to help us in this process, we're going to create in and out tables for y equals x squared, y equals x cubed, y equals the square root of x, and y equals 1 over x. So for y equals x squared, we're going to put in negative 2, negative 1, 0, 1, 2. And when you do, you get 4, because negative 2 squared is 4. You get 1, 0, 1, 4. This must be in your notes, or I will not give you credit. You'll be get bad grades. Get it on your notes. Okay? Okay, thanks. Okay, so that is for the y equals x squared one. For the y equals x cubed one, we are going to have negative 2, negative 1, 0, 1, 2, and you get negative 8, negative 1, 0, 1, 8. Yeah. For y equals the square root of x, we can't put in negative 2 because you get undivided, imaginary number. So we got to start with 0, and you get 0. 1, you get 1. I'm not going to put in 2, but I'm going to put in 4 because the square root of 4 is a whole number of 2. I'm going to put in 9, and I get get 3. Yeah, go, yep. And lastly, we have 1 over x. For that one, you can still put in -2, -1, 0, 1, 2. -2 gets you -1/2. -1 gets you -1. 0 gets you undefined. 1 gets you 1. And 2 gets you 1/2. Yay, go, you. These will help you with your examples that we're getting ready to do and your homework. If you don't have them, bad. Get them in there. Okay, so on these problems, you are going to give me an original in out table. You're going to give me a new in out table. And then you are going to graph. With the original in out table, you just copy down what you just wrote in your notes. So, we have to decide which table to use. So it's y equals x squared minus 1. So should we use the y equals x squared 1? Or should we use y equals x cubed? Or y equals the square root of x? Or y equals 1 over x? You should all say the x squared one, Miss Albers, because it is x squared. So we're going to do -2 for -1, 1, 0, 0, 1, 1, 2, 4. Do you need to memorize those? If that helps you, yes. But you really don't have to memorize anything. All you have to remember is your ends, and then you can square it and figure out. But anyway, so here's our original. We have to decide what happens for our new. Since it has that -1 there, is it going to affect x or y? You should say that it affects y by subtracting 1. So our x's stay the same. Must you show the original in out table and the new in out table and show on the new in out table what is happening? Yes. If you do not tell me what you did from this table to this table, I will count it wrong on your test. Some of you missed that on World of Functions. Don't miss it twice. So if we subtract 1, you get 3, 0, -1, 0, 3. So we're going to go over here and we're going to plot our dots. Some of you are like, how do I plot a dot? Well, your x-axis is here, your y-axis is here. Go over 2 and up 3. Bam. Go over 1 and stay at 0. Go stay at 0 and go down 1. And so on and so forth. And you get your lovely little parabola. Yay, go you. Alright. So, if we look at the next one, we got y equals x cubed plus 1. Pick your new in-out table, make a new in-out table, and graph that all on your own. So pause the video. You should have picked x cubed for your in-out table. So -8, -1, 0, 1, 8 should be your original in-out table. Your new in-out table should be x and y plus 1. So x stays the same, easy enough to copy down. Y, you add 1, so -7, 0, 1, 2, and 9. So we're going to go and we're going to graph. So we go over to -2. We got to go drop down to -7. We go over to -1 and we stay at 0. We stay at 0 and we go up 1. We go over 1 and up 2. We go over 2 and up 9. So there is our lovely curve. Yeah, go you. Pick your new original in-out table, new in-out table, and graph. So pause it, replay it. Original is the square root of x. So we have 0, 1, 4, 9. So 0, 1, 2, 3. For our new in-out table, we have to change x this time because it's underneath there, so it's with the x. It's not out in here. So we are going to add 2 to x because it's the opposite. So instead of having 0, we have 2. Then we have 3. Then we have 6 and 11. So our y's all stay the same. So we go over 2, stay at 0. We go over 3, up 1. We go over 6, up 2. And I'm not going to graph the last one because I don't have enough room on my paper. Yay, go you. Try this one. You should say your original is x cubed because that little cubey there. So if it's x cubed, we have the -2, -1, 0, 1, 2. So -8, 1, -0, 1, 8. So our new, we got something going on in here, we got something going on out there. So there's something going on in here, makes x change by adding 1. There's something going on out here, makes y change by adding. Notice the y was the same as what the equation was, the x was opposite. So if I add 1, I get negative 1, 0, 1, 2, 3 for my x's. For my y's, I get negative 6 because I'm adding 2, 1, 2, 3, and 10. So we go over to negative 1 and down to negative 6. We stay at 0 and we go up 1. We go over 1, up 2, over 2, up 3, over 3, up to 10. Bam! There's our graph. Yay! Go you! Alright, so now we got 4 times the square root of x. Do your magic. So you should say your original is 0, 1, 4, 9. So 0, 1, 2, 3. Your new is going to change your y's by multiplying by 4. That is a 4y, not a yy. So we would say 0, 1, 4, 9 for our x's. Our y's become 0, 4, 8, 12. Holy Toledo. So 0, 0, 1, 4, 4, 8. Oh, that's not 4. That was only 2. So go over 4, 1, 2, 3, 4, and update. Bam. And there's our curve going up and increasing rapidly, but we still have our nice little half hill. Yay, go you. Alright, last example. You got this. Decide what your original and out table is. You should say the last one, 1 over x. So we did negative 2, negative 1, 0, 1, 2. We said negative half. We said negative 1. We said undefined. We said 1. And then we said a half. Alright. So the 2's down in the bottom. If the 2 had been anywhere else but with that x, we would be affecting y. But since the 2 is down in the denominator with that x, that means we're changing our x values. And what we're going to do is we're going to cut our x values in half. We aren't going to multiply them by 2. We're rather going to divide by 2 or multiply by a half. So y stays the same. X gets cut in half, so negative 1. Then a negative half. Then 0. Then a half. Then 1. Plot this and you're done. So go over 1, down a half. Go over half, down 1. Draw your pretty little half of an L. Go over half, up 1. Go over 1, up a half. Draw your pretty little L. Remember, these have a vertical asymptote. We can tell that by looking at the denominator. What makes the denominator 0? And we said that that was at 0, undefined. So, okay, go you. Please come with questions over this for next time. Oh, wait, I lied. We have one more example. So, we got negative cube root. Why didn't it give us a cube root thing? But we're going to do negative 8, negative 1, 0, 1, and 8 for our original. So we get negative 2, negative 1, 0, 1, and 8. So the negative being out in front affects the y. So we multiply y by negative 1. We got negative 8, negative 1, 0, 1, 8. These change to 2, 1, 0, negative 1, negative 8. How about that should not be 8, that should be 2. 2, negative 2. Alright, so we go and graph. We go over to negative 8, and we go up 2. We go over to negative 1 and up 1. So our curve changed across the x-axis. Yay, go you. And that is it for this section. If you have questions, please come with them next time.